Hello students, in this video we'll study about towards the quantum mechanical model of atom. Now this is quantum mechanical model which was proposed after the Bohr's model, after the failure of Bohr model. Now there were two developments which led to the contribution of this new model after Bohr's model. So there were two things that came into being at that time. First is the dual behavior of matter, which was proposed by Broglie, and Heisenberg's uncertainty principle. First, in this video we'll only study about the dual behavior of matter, which was proposed by Broglie. Now since it was confirmed that photons, they have momentum and as well as wavelength. Okay, so similarly Broglie, he suggested that matter should also exhibit dual behavior, that is of particle also, of wavelength also. Like photons, they are a part of light, they are small packets of lights, right? So like photons, they have particle nature also and wave nature also. So Broglie suggested that matter should also have dual behavior of particle as well as wave-like properties. Okay. By this, he gave a relation lambda is equals to h by mv, where h is the Planck's constant and p is the momentum of the electron. Now this was confirmed. How was it confirmed? When the electronic beam of light was tested with diffraction. So it was seen that electrons do show the property of diffraction. Hence it was confirmed that electrons also possess both particle and wave-like properties. Okay. Now this principle was put into use in making electron microscope, which was based on wave-like behavior of electron. Now since ordinary microscope uses the wave nature of light, okay, this electron microscope electron uses the wave nature of electron. It is a very powerful tool and it can magnify up to 1 million times. Okay, sorry, 15 million times. It can magnify up to 15 million times. Okay. Now what did actually Broglie say? That objects in motion, they have wave character, but ordinary objects, they do not show wave character because they have a very huge mass. Since you can see in the formula that the wavelength is inversely proportional to mass. So objects which have a very large mass, they will have very small wavelength. So day-to-day objects, ordinary objects which have momentum, which have some velocity, which show motion, they do not have wavelength, which because it's very negligible. Okay, because of a very large mass of such objects. Okay, so their wave properties cannot be detected due to this, due to their large mass.